Hello everyone. Now I'm going to teach you a very easy and important algorithm known as Huffman coding for computer science engineering students. Here is a short definition for Huffman coding. Huffman coding is a last least data conversion algorithm. It assigns the variable length code to input character. The length of the code are based on the frequency of corresponding character. The coding makes sure that the encoded data can always be uniquely decoded without confusion. Now let me show you the algorithm of Huffman coding which is useful to solve the program. There are 6 important steps to solve the Huffman coding. Now I will explain those 6 steps with an example. Here is an example with character and frequency of A10, E15, I12, O3, U4, S13, T and 1. Now the first step is to arrange those character and frequency in a ascending order. After ascending, we have to add the first two character and frequency. After adding those two, we get 4 which is created as a internal node 1. Now the left node as T with frequency 1 and O with frequency 3. Now the step 2 is to rearrange the tabular column with internal 1. The internal 1 is equal to the character U with frequency 4. So let me put the internal 1 in the first. After putting the internal node, add those two. After adding those two, we will get 8 as a internal node 2. Now we have to split this also into right and left node. The left node contain 4 and the right node contain U with frequency 4. And also we have to split the internal node 1 which is 4. Again, we have to repeat the step. Now, the third step is to add the internal node 2 in the tabular column. Now, the internal node 8 is less than A. So, I am putting it in the first. After putting, I am adding the first two node. So, that is 10 plus 8 which is 18. We have to split the 18 also into left and right node. The left node contain 8 and the right node contain A with a frequency of 10. Also now we have to split the internal node 8 into 2 and the internal node 1 4 into 2. The fourth step is to add the internal node 3 in the tabular column. The internal node 3 is greater than the character E of frequency 15. Now we have to add the character of first two with their frequency. We will get 25. Now the 25 is splitted into left and right node I with frequency 12 and S with frequency 13. Fifth step is to add the internal 4 in the tabular column. The internal 425 is greater than the internal 3. So let me add it to the last of the tabular column. Now we have to add the first two which we get 33. Now we have to split the 33. The left node contain E with the frequency 15 and the right node we have 18, the internal node 3. Now we have to split the internal node into left and right. The left contain internal node 2, 8 and right contain A with frequency 10. Now we have to split the internal node 2 and also internal node 1. Now in the sixth step we have to add the internal node 533 into the tabular column. Now the tabular column contains only two nodes and we have to add those two nodes. After adding we get 58. Now we have to split the 58 into left and right node. Left node contain 25 which is internal node 4 and right node contain 33 which is internal node 5. We have to split the internal node 4 and 5 into right and left. After splitting, we get the internal node 3, and also we have to split the internal node 3, and then we get internal node 2. Also, we have to split the internal node 2, and after splitting internal node 2, we get internal node 1. So, finally, the tree is created. Now we have to assign 0 to the left node and 1 to the right node, assigning the values for each and every node. After assigning, we have to write the values for every character. Here, A is created from the right node of 58, and again a right node of 33, and again a right node of 18. So the value is 111. Likewise, E is created from the right node of 58 and left node of 33. So we are getting the values as 10. Now for I is created from the left node of 58 and left node of 25. So 0 and 0. Then O is created from the right node of 58 and right node of 33 and left node of 18 and left node of 8 and right node of 4. Now we are getting the numbers as 1 1 0 0 1. Likewise for you, right node of 58 and right node of 33 and left node of 18 and again the right node of 8. So we contain the numbers as 1 1 0 1. The S is created from the left node of 58 and the right node of 25. So 0 and 1. Finally, to find D, the right node of 58, the right node of 33, the left node of 18, the left node of 8 and the left node of 4. The final binary code number is 11000. Hence, the solution has been found out. Thank you.